See, your model runs perfectly fine until suddenly STAAD throws this at you. Base dimension seems improper and the program calculates base dimension at the lowest support level. See, you double check your supports, your geometry, your load definitions and still no clue. See, this error has confused so many, but by the end of this video, you'll know how exactly why it happens and how to fix it confidently. See, today's video is all about one specific frustrating error that pops up when you define seismic loads as per IS 1893 in STAAD. So this issue is directly linked to how the software interprets your model geometry when the ST parameter is used. So basically you will learn the actual cause behind the base dimension improper error, how STAAD.Pro calculates the time period using this ST parameter, and a clean reliable workaround using PX and PZ. So stay tuned till the end and let's check out the solution part. So here is what really happening. See, when you use a seismic load definition like this, let me show you the STAAD editor part that define IR 1893 load. The syntax is displayed over here. And you can now see that the ST3 part tells that your structure is a moment resisting frame with brick infill walls. See, in this case, the time period is calculated using that empirical formula from IS 1893 clause 7.6.2. See, you can check out this equation T equals to 0.09 H divided by square root of D, where H is the height of the building from the base to the top. D is the base dimension along the considered direction. It is X or Z. STAAD tries to automatically compute the D by identifying the lowest support level, assuming that this particular level is your plinth level. But here is the catch. See, in many real-world models, especially on slope terrain or pedestal supported frames, supports are not all at the same level, right? And as a result, STAAD cannot accurately calculate the base dimension width D, so it fails to compute the time period T and throws this particular error. So it's not about a wrong command, it's about STAAD not being able to extract the reliable geometrical data. Now let's talk about the solution part. Now see, to fix this, remove the ST parameter completely and take the control of time period calculation. Follow the steps one by one. See, in step 1, what you can do is manually calculate the time period for both X and Z direction using this following equation. Now, in step number 2, replace the ST parameter with PX and PZ like following syntax. So here, T1 is the time period in X direction, T2 is time period in Z direction. See, both the values come from your manual calculation using the height and base dimension. Now, STAAD doesn't have to guess anything and your model runs cleanly without any error. Now, just for your understanding, let me take you to one example. Let's say our building height is 18 meter and the base width is 12 meter in the X direction. Now, then the time period that you will calculate utilizing this particular formula, it will be around 0.47 seconds. So just plug in this value into PX and PZ as needed. So here are the key takeaways. See, this particular STAAD error comes from the geometry mismatch at support level. It's triggered when using ST3 or any ST value in the seismic load definition. Now the fix is simple. Manually calculate time period and replace this ST parameter with PX and PZ. Always make sure that the height and the base width are based on the actual structural dimension. Now you know exactly what to do when this warning shows up. No guessing, no frustration. Now if this helped clarifying a nagging issue in your modeling workflow, hit the like button, drop your questions in the comments and subscribe for more structural modeling insights that actually make sense. And always remember, don't just learn software, learn concepts. I'll see you in the next video.